So this time we have a really, really long polynomial function here. All right, so that's negative 5 over 1,000, and then all this stuff. All right, and then you have a plus x here at the very tail end, which makes it kind of weird. All right, this is a 5th degree polynomial. All right, so this is a 5th degree. All right, so this is to the second power, the first power, the second power, and those are what's being multiplied. All right, this extra x over here is being added, so this is not changing the degree over here. So I've got the graph here for you, but now I need to kind of clean it up. So I'm going to make my y minimum a little lower, and I'm going to do the regular thing with the x values, make it negative 5 to 5. And for my y minimum, I'm going to try like negative 20 this time. Graph that. Let's see if that does it. Yep, negative 20 did just fine. All right, so we have 1, 2, 3, 4 critical points, 4 turning points, 1, 2 minimums, 1, 2 maximums. So this time, I'm not going to go ahead and find all the x-intercepts this time, but it'd be there, 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 and there. And the range, you'll see from the picture here, it goes up forever and down forever. So this one, it's negative infinity to infinity. Not that interesting when you're dealing with 5th powers. Here we go. I'm going to do minimum. Oh, that's what I was going to do different this time. To find that minimum, instead of just dragging my arrow all the way over there, I'm going to count these tick marks. So I already know this is going to negative 5. I just want that to be to the left of that spot. So negative 1, negative 2, negative 3 would work. I'm going to go ahead and do negative 4 right there. So just type in negative 4 for your left bound. That way you don't have to drag the arrow so far over. All right, and then to the right of it, anywhere to the right of that. All right, so I'm going to go, this is like, well, I got to be careful because there's another hump up here, huh? I'm going to do negative 1, negative 2 right there. So you could drag that arrow to the right if you wanted to. I'm just going to do negative 2. And that puts it right there at that value. And then guess, press enter. All right, so negative 2.69. I'm just going to do 2 decimal places. I'm giving up on that 3 decimal places. Negative 2.69, comma, negative 2.68. So turning point, negative 2.69. That is a minimum of negative 2.68. All right, that's my next one. Maximum. I'm going to go ahead and go to the left of it. This one, it's just easier to actually use the little dot dots. So negative 1.08, 1.08, comma, 9.19. I'm just going to leave it as 9.18. All right, so that's another turning point. 08. And 9.18 is a maximum. Oh, I should make these equal signs. Yeah. That minimum. Yeah, that's equals. Equals negative 2.68. All right, going down to this one. All right, so calc. This is a minimum down here. All right, I just want to be to the left of that. Well, it looks like I could use 1 or a 0. All right, so I'll just do 1 for my left bound. All right, you'll notice that is to the left of that minimum. Now to the right of it, I could drag it over. Or let's see here, 1, 2, 3. 3 will be to the left of that, but, 3 will be to the right of that, but it'll be to the left of that hump. So 3. see how my minimum is between those two spots that I chose. And enter for my guess. All right, so let's see here. 1.58, comma, negative 17.32. And let's see here. 1.58, and it's a minimum. So negative 17.32. Oh, you can barely read that over there. Oh, good thing you can barely read it because it was actually in the wrong line. Darn it. That was a minimum, negative 17.32. Okay. And then one more up here. Maximum this time. All right, so we got 1, 2, 3. I could do 3 for my left bound. And then 4 would be right there. 4 for my right bound. Then enter for the guess. So you can use these tick marks to just, instead of using the arrows so much, you can use the arrows if you want to. They probably are easier. But you can just use the buttons on the calculator if you like. The digits. 3.52 and 3.51. All right, so my turning point is that 3.52, and the 3.51 is a maximum. Okay, so we got all of our critical points identified. 1, 2, 3, 4, 5. Is that right? Yeah, there's 5 x-intercepts because it's to the 5th degree. All right, we're at the 7-minute mark. I'm going to do this kind of piece by piece. It decreases from negative infinity to that x value, negative 2.69. Negative infinity to negative 2.69. To that one right there. And then it is increasing from negative 2.69 to that x value. So it's increasing on negative 2.69 to negative 1.08, which is that turning point. Notice these are just going to go in order. And then it's decreasing again from that x value until it gets to that x value. So it's decreasing negative 1.08 until it gets to 1.58. All right, remember, or notice here, we are using these x values. We're not using 9 to negative 17. So that was those two. And then it's increasing, so increasing here, from 1.58 until it gets to this x value, 3.52. All right, and then from 3.52 on to infinity, as it goes further out to the right, this thing is going downhill. So it's also decreasing from 3.52 to infinity. All right, so notice it just kind of, it decreases from negative infinity to that value, and then it increases from this one to this one, and then it decreases from negative 1 to positive 1.58, and then it increases from 1.58 to this one, and then it decreases from that one on to infinity. That's why I like putting the turning points in numerical order. That way I kind of see how it all works. Between pieces is where it increases or decreases. All right. I'm not going to do all of them, but for this, if I was doing the algebraic notation, it would be all the x values that are greater than 3.52. All right, for this one, we're describing all this decreasing. So it's all the numbers before negative 2.69. I think that was enough for this one.